and our speaker is Yanis Markevich. Yanis is a structural engineer with more than 12 years of experience in building design. He has been using parametric approach in many projects to design steel and concrete structures. Buildpoint is based in Finland, and we offer software and professional services related to building and construction industry. We are part of Point Group company, which also includes CivilPoint and AssetPoint. CivilPoint provides infrastructure sector software and professional services, and AssetPoint provides asset management solutions. We offer our clients comprehensive consultation, off-the-shelf and custom software, quality training, as well as professional support services. We select and partner with the best suited software providers within the industry and region. Our software experts offer professional training for the software that we promote or tailor it to the client's needs. At the end of the webinar, I'll introduce you our offering for the Rhino Grasshopper online trainings. During the webinar, you can ask questions using the question and answer dialog box from the webinar control menu. We will answer questions at the end of the webinar. But further notice, I'll hand over to our speaker, Yanis, who will go through the content of today's webinar. So go ahead, Yanis.
Thank you, Elina. I will now share my screen. So can you please confirm that you see my screen?
Yes, we can see it.
So good morning, everyone. Thanks for joining. So yeah, today's webinar is about the algorithmic modeling in structural engineering and bridge design using Rhino 3D Grasshopper. So shortly about the agenda today's. So first I will give my take on what parametric design is, then short introduction to Rhino 3D Grasshopper and Grasshopper Tekla Live Link, and then some examples how the structural engineers could utilize this parametric approach and Rhino 3D Grasshopper, as for example, extracting information from 2D drawings, linking Grasshopper algorithm to calculation software, and creating documentation using Grasshopper. So what is parametric design and how we can use it and benefit from it? We have all at some point used a spreadsheet to solve a specific mathematical problem, starting with chosen values, and under certain rules that we have imposed on the system, we are able to instantly obtain very complex results, which also can be immediately recalculated by simply changing the original parameters. The same approach can be used to create geometry. Here we have a concrete bridge deck and a pier, which is created using this parametric approach. As input parameters, there is a road line level at the specific X and Y coordinates, the ground level, and the height of the diaphragm. And the algorithm then calculates the height of the pier. If any of the input parameter changes, then the height of the pier changes accordingly and automatically. The ground of parametric design is the generation of geometry from a family of initial parameters and the formal relations they keep with each other. It is about the use of variables and algorithms to generate the hierarchy of mathematical and geometric relations that allows you to generate not only the certain design, but to explore the whole range of possible solutions that the variability of initial parameters may allow. This approach is great for iterative processes and creating complex geometries. There are several designated tools for parametric design on the market. One of those is Rhino 3D Grasshopper. Rhino 3D is a NERD-based 3D modeling software developed by McNeil Company. Rhino is being used in many different industries, from jewelry to architecture to structural engineering. Grasshopper is a visual programming language and environment that runs on top of the Rhino. algorithms are created by dragging components onto canvas. The outputs of these components are then connected to the inputs of subsequent components and so on. Advanced uses of Grasshopper includes parametric modeling for architecture and fabrication, lighting performance analysis, building energy consumption analysis, and many more. By adding third-party plugins, Grasshopper can be customized for specific needs. I must add that Grasshopper has very steep learning curve if compared to using traditional programming languages. So one small example to give you look how it works. Here I have the algorithm that generates simple steel arc bridge. On the left-hand side, I have the input parameters, and on the right-hand side, I have the algorithm that generates the geometry of the bridge. So by simply changing some of those parameters, I can create the two nodes that controls the length of the bridge, and dragging numerical slider, I can change the y coordinate of those points. Then algorithm calculates and creates the center lines of each of the bridge elements. And if I now change the input parameters like the height of the arc or the number of the cross beams and the suspenders and the width of the bridge, then the geometry changes immediately and according to my applied changes. When the center lines are now created, we can apply cross sections to them. There is multiple ways how can we do this, either by lofting to cross sections or doing extrusions. And now we apply the cross sections to all the members. So the basic geometry is done. And of course, if I now going to change any of the parameters, then changes are immediately applied to our model. Tekla Grasshopper Live link. This link enables algorithmic modeling for Tekla structures using Rhino Grasshopper. The link is a set of Grasshopper components that can interact with objects in Tekla structures in a live mode. Using this link, it is possible to create and modify objects in Tekla. Also, it can be used for adding shapes and profiles to Tekla catalogs. You can download this Grasshopper Tekla Live link at the Tekla warehouse. So one example how it works. So here I have the same Rhino bridge model, and I open the empty Tekla model at the same time. So now we can use the beam component from the Tekla Grasshopper menu and transfer the beams immediately to Tekla. Then I can get access to the Tekla profile catalog and choose the profile from this catalog and assign to corresponding members. Also, we can control the position of the members. If necessary, we can add offsets and so on. So now I'm going to transfer all the members to Tekla. So one more way how to use this live link, we can apply connections between Tekla elements using Grasshopper. So I will choose the component from the Tekla menu and input main parts there and secondary parts. And then what's left to do is to choose the component from the Tekla catalog. So in this case, it will be connection between the main beams and the suspenders. I use this tension component. So you can see that at each node, it creates the component. So let me now copy this and use for another connection, in this case between the cross beams and the main beams. So I just change the secondary members, change the components, and we get the correct connection there. Very powerful thing is that we can control the component parameters from Grasshopper. In this case, I want to control the number of bolt rows in this connection. I just add the numerical slider, and I need to know the correct name for this parameter there. So I connect those two values, input in component, and just by simply dragging the slider, we can change the number of bolts. One more simple example how the Grasshopper can be utilized. This algorithm will read the mass center or center of gravity of the element, and we'll add at equal distances 2 lifting lug components. So, and then by dragging numerical slider, we can change the distance to the center of gravity. So this is a really simple example to show that Grasshopper Live Link can be used not only to create some really complex geometries, but also for simple day-to-day tasks. Grasshopper is a great tool for extracting information from 2D drawings. It can be used to develop 3D models based on 2D drawings, estimate quantities, or just simply automate the editing of 2D drawings. Rhino supports DVG, DXF, DGN, PDF, and other file formats for both import and export. Here I have one example where I will generate the 3D ground model, solid object, based on 2D DVG topography file. So first, I'm going to, using layers, we'll select all those points, and then the Grasshopper will read will find the closest text object to each of those nodes, and will read the Z coordinate value from the text object. And then when it's done, it will combine all that information and will create in the 3D space points in correct Z, with correct Z value. And through those points, we can draw the surface. And this surface we can then extrude into 3D solid object. As I now have open Tekla at the same time, we can transfer this 3D object directly to Tekla for the drawings or as a reference. So, and of course, if I would have at this point not only the surface geometry, but also some geotechnical survey data, I could use this to generate all the layers of the soil there. And one more example, this one is more building related. Here I have the architectural 2D floor plan, and I would like to quickly use this to generate the 3D structural model in Tekla. So I will start with converting grid lines from those DVG objects to grid lines in Tekla. We just select the lines there, and using the grid line component from the Tekla menu in Grasshopper, we in one go create the grid line objects in there. Next, I will select the wall line in 2D drawing, and it reads the start and end point and creates the wall layout panel in Tekla. So here I've created the text object near this line where I can control the thicknesses of individual layers of this sandwich panel. Also, I can control here the height of the wall and the bottom level. In the similar way, we can create also the windows openings there. I have created the lines there for windows openings, and I have set the text attribute there. It reads the bottom level from this text attribute and the height of the window. It always finds the nearest text object within the specific layer. So if I would have all the windows with the same height and bottom level in this building, I could set up just one text object there and control all those through this one text object. It's done. I can select all the facades there. In this case, I will create one wall layout in Tekla for one facade, but and then I can split those in elements later in Tekla, or I could do the splitting also in 2D. Then there is just more lines to select there. And now we have all our walls here, and I also have set some parameters for components, so each of those wall layout elements gets connected at the corners. Grasshopper can be used to build also the calculation models. Many structural calculation softwares has introduced their links to Grasshopper. Some of those provides only geometry manipulations, others provide full spectrum from geometry to adding loads and combinations and reading back results. Such softwares has links as Tekla Structural Designer, Global RFM, FEM Design, and many others. In this example, I will demonstrate how we can transfer information from the Rhino and Grasshopper to Global RFM calculation software. Here I have the same bridge model, and it basically requires just the two Grasshopper components to transfer all this data about the lines and the cross sections to Global RFM. Here we have our model there. Then I will select the corner nodes of this bridge and we'll add the supports there. For the supports, we can control all the necessary degrees of freedom. Here, let me enable the component. And now we have the supports there in RFM. Also, it can be used to add other things like, for example, hinges on the member ends. Grasshopper can be used not only to generate models for other calculation softwares, you can do the calculations also within the Grasshopper itself. Caramba 3D is a parametric structural engineering tool which provides accurate analysis of trusses, frames, and shells. It is available as an add-on for Grasshopper. As an output, you can get forces in members and surfaces, stresses, results for buckling check, and the code check for EC3 for steel members, and other results. So let me demonstrate it. Here I have the bridge geometry. I can apply the cross sections to them. Caramba provides steel cross section databases with all the typical cross sections. So we select the cross sections, we can apply the loads. There is multiple type of loads like gravity load, initial stress, temperature loads, point loads, line loads, and so on. And let me add one more load. In this case, I will add the surface load. And for this, I need to define the direction in which load acts. That would be the Z direction. Specify the magnitude of the load. That would be the 15 kilonewtons per square meter. And this one, this component, of course, needs a surface to apply to. For this, I will utilize the cross beams and I will loft the surface through those cross beams. This surface I will link with the load component, and this load component I can apply for the model. So as you can see, the load is now added, but it acts on the wrong elements. The Caramba provides us possibility to use filters. So I will tell to this filter to apply load just to the cross beams, not the other elements. So as you can see, now load is correctly distributed between the elements. And if I would now change the number of the cross beams, load gets automatically recalculated. So it's a really convenient way to add the loads. So in a similar way, I can also add the hinges on the member ends. So I use the join component, set the necessary degrees of freedom, link this with our model. For now, it's a hinge on every member's end. If I want, I can use the filters again. So I will add the hinges just on the cross beams and the suspenders and the bracings of the bridge. So these filters, then I link with the join component. And then this join component can be linked with our model. When the model is calculated, we can view the results. As for example, we can view the deformed shape of our structure, change the magnitude of the deformations, the scale. Also, we can use to view different kind of results, for example, axial stresses there, displacement, the colors. We can view internal forces, like for example, bending moments, in Y and Z and torsional bending moment and shear forces in both directions and so on. All these values can be viewed also in like text format. I can set also the color legend. In this case, it will be for the stresses. And one more thing that Karamba provides us is the checks for the steel elements according to Eurocode 3. So I will use the utilization factor component, link with our model, and here I can view all the utilization factor for each of the bridge elements. If I would like view this only for the certain elements, not for the all, I can again use the filters. In this case, I will want to view results only for the arc members. Also with the Karamba 3D, you can do the buckling check. In this case, I have set it to check 4 different critical buckling modes. So with the numerical slider, I can switch between those. And of course, you can view also the corresponding critical load factor for each of the buckling shapes. And the last topic is the documentation using Grasshopper. So Grasshopper can be used for generating reports and drawings. Many files formats are supported on input and output like TXT, Excel, CSV, DVG, and many others. Let me demonstrate one simple example. I would like to forces from this Karamba model transfer to Excel sheet for some further manipulations and calculations. So I select the display forces component. I have set up some Excel template with some formatting, and then I use Excel write component, link in all the data that I want to transfer to this Excel file. Also, I provide where the file is located, the path to the file, as well the name of the sheet and the names of the columns where to put those data in. And then I use the switch to turn this component on, and all data now is transferred to the Excel file. If I open now this force Excel file, we will see that all the forces from members are in there. So this is the really great way to create the reports. Some may even prefer this way to create reports from Tekla than to use the, let's say, template editor. It could be really useful in some cases. So that would be it from me today. I will give microphone back to Elina.
Okay, thank you, Janis. I guess now you still have time to ask questions using the questions and answers dialog box from the webinar control menu. While we are waiting for the questions, I would like to take this opportunity to introduce our upcoming online trainings. Can you press the next slide?
Yes, sure.
So the first one we have a set of 3 trainings lined up for at the end of this month. So the first one is the basics of Rhino Grasshopper. So you can participate into this 2-hour training just to learn the basics of algorithmic modeling using Rhino Grasshopper. You don't need any previous experience to participate to this first training. The second training is more for intermediate level from the first one, and it improves your skills using the Grasshopper 3D, and it gives you more of an overall understanding of parametric thinking. We will use examples related to the structural engineering. And the last training, or the third training, is about this Grasshopper Tekla Live Link. So if you're working with Tekla Structures, so then you will learn in this training to understand and use the Grasshopper Tekla Live link for the automation of the Tekla Structures modeling tasks. All the trainings will be 2 hours long, and you can register for the trainings from our website events page. Okay, I'll guess we go to the questions now. There is 2 questions at least. So first one, is it possible to transfer forces calculated by Karamba to Tekla? I assume this for Tekla Structures. Can you answer this?
Yeah, sure. It's possible to read those forces into Tekla as user-defined attributes and write on that Tekla end member forces. And in fact, you can read and write to Tekla all the user-defined attributes. So it's possible, yes.
Yes, okay. And then there's a second question regarding IFCs. Is there a way to edit the IFCs using the Grasshopper?
Yes, for the Grasshopper and Rhino, there is this visual RQ plugin, which allows you to read in the IFCs and then do some editing on those IFCs, even create, add some new elements there, change the attribute values for the IFC elements, and then write out or export the new IFC or updated IFC file. So it's very much possible, yeah.
Okay, thank you.
And I think we have some more questions in the...
Yeah, regarding the webinar recording, we will share it with you after the webinar. And then there's a questions regarding about more examples how Grasshopper could be used for buildings modeling. Do you answer something? No.
No, yeah, we could. I don't know. We can later share some videos, I guess, on some more building-related examples. I have something.
Yeah.
So.
And I guess the trainings are more focused.
Yeah, and maybe maybe on the trainings we can also go through some building-related examples as well.
We can also, if your company is something more focused on more specific things, so we can do tailored trainings regarding the Grasshopper Rhino as well. Then I guess there's one more question regarding more for the infrastructure. So do you have experience about using Grasshopper and parametric design in infra design, like roads, streets, utilities, and so on?
Yeah, even though myself, my background is building design, I have participated in the project in the Latvia and Riga, quite big infrastructure project for there was built a couple of kilometers of viaducts, and then this model was developed using the Grasshopper, the Tekla Grasshopper Live link.
Okay, thank you, Yanis. I think that's all for the questions, and we are getting at the end of the webinar. If you could show the last slide of the on the presentation. So thank you, and thank you all for participating, and feel free to contact us through our webpage or the email address below. And have a nice day.
Thank you. Bye.
Thank you. Bye.